See? Our presenter tonight is Dr. Alan Benimoff. He's in the Department of Engineering and Environmental Science at the College of Staten Island, CUNY. I'm going to stop sharing my screen and transfer over to Dr. Benimoff. So just bear with us for 1 second.
Okay, thank you, Chris. I'm gonna see if I can get this. Okay. Okay, thank you for inviting me to give this presentation. I appreciate it. And I want to get the word out also. Staten Island is part of New York City, as you know, and we have great geology, I'll tell you right now. And so I'm going to talk about the cultural geology of Staten Island, but here's my outline. I'll talk about, I got to give everybody an idea of what the geology of Staten Island is. It's really important and it's really extraordinary. Then I'll go into the cultural part of this, and then I'll give an overview of the Staten Island serpentinite that's part of this. And if I have time, I'll go into the hurricane history of Staten Island, which is also a cultural type of topic. So we look at how significant the geology of Staten Island is. It's an island about 13.7 miles by 7.7 miles, sort of elliptical in a shape there. You'll see a map of this. And here's the good news. We have all of this in a small island, 13.7 miles by about 7.7 by 13.7 or something like that. We have ancient plate boundaries or evidence of it. We have igneous rocks, sedimentary rocks, metamorphic rocks. We have cases of where we had fusion of the sediments by magma. We have glacial deposits, features and landforms. We have ancient stream deposits. And the New York City DEP has put blue belts into the south part of Staten Island for stormwater management instead of putting sewers as in most of the city. So anyway, we'll start with this map that I took the data from USGS in the state of New York. And if we take a look at this, let me just get my pointer here. So here's the island right here. Here's the scale right here. And right here is the Staten Island serpentinite, makes up the hilly part of Staten Island. Highest elevation is around 411 feet above sea level. Here's the Palisade sill runs through here. And the rest of the Newark Basin rocks. We have the Lockatong argillite, Stockton, Arcos, and we have the Passaic. Then we have on the south shore here, we have the Raritan and the Magathy formation. So that's our bedrock. But we also have superficial rocks so here, and well, actually, we have the terminal moraine over here, an outwash plain, artificial fill. We have plenty of glacial till, and we have some lake types of deposits. And if we look at the island here, I just have some comments about the ancient plate types of boundaries here. So if you consider, my take on this would be that the serpentinite represents an ancient convergent plate boundary. And the Palisade sill in the Newark Basin suite here is an ancient divergent plate type of boundary here. So we have these right here, which are a couple of maybe 3 or 4 miles from each other. And so we go back to a map like this. At the time the serpentinite formed, there was a tectonic arc here that crashed into the ancient North American continent named Laurentia. And we have that. And then here we have the map from Little and Epstein, 1987. My colleagues at Brooklyn there put this all into a neat type of package here. And then we have a cross section across this, say from west to east, and this is what we see, and you can see it right over here. So the serpentinite sits here, then we have the Heartland rocks over here and some other rocks over here. The Palisade sill is over here, and the rest of the Newark basin rocks are here. So here's our outcrop of serpentinite. It's actually filled in now because they came here and they widened the I-278 and they filled all this in and so forth. But here it is. And so it's a pale green rock, the product of low grade where the mantle rock was metamorphosed from pyroxenes and say olivines and so forth. And an average sample of Staten Island serpentinite contains 66% of this here and 27% asbestos chrysotile. In 1858, the H.W. Johns Manufacturing Company began mining low-quality chrysotile asbestos from the serpentinite body on Staten Island for the local manufacture of fire-resistant shingles. The H.W. Johns Manufacturing Company merged with the Mansville Covering Company. The new company, John Mansville, became a world leader in asbestos mining and asbestos-related manufacturing. So here's what we see. Regular people walking around here will see this, and this is what we interpret it as. So as you see here, we have an ancient convergent plate boundary here, and we had an iron ore crashed in and here, and we have a piece of the mantle here that became the Staten Island serpentinite, abducted onto the ancient North American continent known as Laurentia. And then we go to the Mesozoic rocks, and here's what Pangea looks like, and then furthermore here. And then here we see, if we look at stop 2 here, we have an outcrop here in what's known as Graniteville Quarry Park, which I've been working on for the last 3 decades. And we have an unusual occurrence here that's really important to point out because I think it's kind of rare. So over here, here's what it looks like. It's a view looking, here would be the what was here as a quarry. Then they began to fill it in here. Now the quarry is not operating. It's been now, and it was operated back in the early 1900s for trap rock. And here's what it looks like now. So they filled in the part over here. And here's where the quarry is. And about over here, we have a very interesting outcrop here that you could see. So I'm going to be talking about this. And here's what it looks like. Now there's 3 contiguous rocks here. We have a buff-colored rock over here. And then we have sort of an igneous rock here. And then here's the main rock of the Palisades, still known as the Palisades diabase. And here it is again. So what we have here are 3 contiguous rocks. It's repeated on the other side. So we have the Palisades sill rock, which is the Palisades diabase here. Then we have what's called a Tragediamite in between here. And then we have a partially melted foreign rock body known as a xenolith here. So we have that, and here's a scale here for the outcrop. So what you see here is repeated on the other side. And if we look at the photo micrographs here, you could take a look here. Here's the contact between the Palisades rock and the Tragediamite. And on this side, we have the other contact that you could see right here between the Tragediamite and the right here, as you could see. So here we have the foreign rock body known as a xenolith here, and it makes contact with the Tragediamite, and here's the Palisades rock known as the diabase. And then if we look at this Tragediamite, we have these big clinopyroxenes here in an albite quartz type of matrix right there. So what kind of happened here, and I put this into like a cartoon. So the magma intruded between these host rock layers, and a piece of the host rock broke off here. So as the magma intrudes, a slab of the sedimentary rock breaks and floats up, becoming a becoming a foreign rock body in the Palisade Sill here. Now, we have plenty of these in the Palisade Sill, but what happened here, because of the temperature of the magma and the composition of sodium-rich foreign rock body here, it started to melt around its margins, which you could see over here. And as time went on, the melt zone around this turned into the igneous rock Tragediamite, which you could see over here. And as time went on, we have the three contiguous rocks here, as you could see. So it was, we actually got the photo of this on the cover of the AGU-ES here, as you can see. And so we found an unusual occurrence of this also. We haven't found too many of these, but here's one from Walker and Poldervart's 1942 paper on the South African occurrence, and almost looks the same. Here's the siltstone and it melted around its margins. This is my interpretation of it. And so they also have the three contiguous rocks, but I haven't found too many of these around. So anyway, we analyzed all of this, and what we have here is the actual rock of the sill, AN61, AB 38.8, OR 0.5, and the augite that was in this is EN 34 to 44 for FS 17 to 31, the WO 35 to 42. And then here's some more material on it. The augite contains features here that typically exhibits contact twinning on 100. And here's what it looks like. Now, the Tragediamite is composed not only of quartz albite, a type of matrix here, which are enclosed large discrete crystals of albite and clinopyroxenes, calcium rich. And then we have some calcite, titanite, ilmenite, and other types of accessories in here. And anyway, and we look at the foreign rock body here. It's a hornfels that exhibits a granoblastic type of texture composed dominantly of albite and quartz, and subordinately of calcite, titanite, apatite, ilmenite, and actinolite, and so forth. So we have the three contiguous rocks. And when we look at this, here's here's ORANAB here, and the Tragediamite and these plots over here, the diabase plots over here. Now, when we did a work over here, we see that the trend here, here's the rocks of the Palisade Sill, and here's the rocks of the Tragediamite and its parent over here, as you could see. And then if we look at this, we plotted the North American shale here, and it runs with the with this rock here, and so forth. And then here's what it looks like. So we have a partially fused body in the center here. Around it is the Tragediamite, enclosed in the diabase of the Palisade Sill. Here's some more information on it. So we have a paper on this that came out. If anybody wants to read it, I can put it up there. Now we move on to the South Shore. Now we have this AKR site here of cross-bedded types of sands here, as you could see. We're not too sure about this. Some believe it's the Pensacola, and others believe it's something else, and we're still working on that. And then if we go to the Pleistocene here, what we see here, again, we're going to go over here and we're going to look at some of we actually have the terminal moraine over here at the end, and here it is. So here's where it happens to be. It's at the south end of Staten Island. If you go back one, it would be about over here. Okay, so we have that. And then I'm standing by an erratic at the College of Staten Island here. You could see that. And then back at the Graniteville Quarry, we have a glacial groove. You could see it right there, and so forth. Okay, so if we look at the map here, Here's where we were at the south end. This is the terminal moraine, as you could see. We have glacial till here, outwash plain, artificial fill here and here, and the fresh kills areas over here where they have a garbage dump or landfill. And then also on Staten Island, we have this blue belt type of network, as you could see from the DEP. So what they did here, they took existing streams and they put in these BMPs, and they were able to manage the stormwater with the BMPs. And here's the different blue belts. We have the Richmond Creek, the Mill Creek, and everything else, as you could see. And I went back to the 1902 maps, and I geo-referenced them into the GIS. I thought they were better maps and so forth, and they show a lot of the old types of features. So now we'll move on to the cultural part of it. That's the main focus. So anyway, so here's Staten Island again. This is the map by the USGS, and we looked at that. So we went back, and there were iron mines on Staten Island. They were operated between 1832 and 1881 in the serpentine rock. The ore, they took between 38 weight percent and 55 weight percent iron, and they took about 250,000 tons out. I got this information from the New York Times, May 4th, 1915. I went, and in that article, they claim it's something like a iron oxide, or they were able to get. I couldn't get too much information on this, but I got that. So here's the 1902 map that I geo-referenced, and right here are going to be 4 circles, and they have the locations of the former iron mines, as you could see over here. The symbol is right here, and we have them over here. And I got some images here. Here's what the iron mines look like. So here's the view looking north. Here's a view looking south. So that's what they were quarrying over there. A big operation. And then there were clay works on the South Shore, and the clay was composed of what you see here and so forth. Now the clay was the clay quarry was over here on the South Shore. If I was able to enlarge the map, you would see the symbol here, but that's where they got it from. Anyway, so then the serpentine here was used for some of these churches. And here's the Reformed Church of the Huguenot Park on Staten Island. And fellow Ernest Flagg, 1910, he discovered the beauty of serpentine rock. It was for building stone. And he actually had this church built, you could see here. Church is composed of the serpentine. And here's some words on. In 1918, the little wooden Protestant Reformed Church became ignited from a spark from a train that was running parallel from the site. The small church was quickly burned to the ground. Under the Reverend here, a rebuilding committee was formed, and through inspiration, members approached Ernest Flagg to see if we would consider designing a new church. And this is the church he built. He accepted, and it was very much enthusiastic about the new project that he would take on. He only charged the cost of the building materials and labor, and did not take 1 penny for himself, and took the work very personally. Now, I mentioned here, now the Staten Island Mall here on Staten Island has 2 floors, and they used a certain tile here. And the tile, I tried to find out where it came from. It came from France, from this particular limestone, and it consists of certain it consists of the gastropods, corals, and the bivalves. And here's what it looks like. So they have some shoes here for scale, and here's what the particular tiles look like. And so, but both floors of the mall are composed of this. It is a fine-grained micrite and full of pressure structures like the stylolites, things like that. The tiles appear to have been cut perpendicular to the bedding. The fossils have been recrystallized and really aren't in the greatest shape, but they still show a good view and everything. There's a large, many of the fossils here. There are at least two types of high spired gastropods. They also appear to one type of low spiral gastropod. The bivalves are common in the tiles. They're usually preserved as disarticulated valves of various sizes, but occasionally one finds specimens fully articulated closed valves. A few of them seem to be geopedal structures within them. There's a single specimen what appeared to be some kind of large type of brachiopod. Fragments of algal mats and of coral colonies are also common. Some of the mats look like colonial hydrozoans. So we'll take a look at this. And here's what some of them look like. Here's a gastropod and some stylolites over here on this side here. Here's a gastropod with the main axis going into the tile. Here's a colony, as you could see here, coral type of colony. Here's a cross-section of a bivalve. Here's some more of the corals and so forth. Here's some more of the bivalves. And what we did is we got together with the science, the science personnel in Staten Island who teach, and we had these signs put into the wall so students could come here and do some work here. So here's one over here, you could see it. And it tells you here to locate the fossil, count back 3 floor tiles toward the store and so forth. So here's one. Here's a gastropod sign here, tells you, and here's a second gastropod sign somewhere else. And then the local paper came down here, and I brought my students here at the time. And you can see the outline of the mall over here and so forth. And they were able to, prior to the mall opening that morning, they were able to trace some of these fossils and do some work on them and so forth. You can see that over here. And then somebody called me up from the local school here, and on the wall here, they had some rocks, and you could see some these brachiopod and corals and things like that. And then in the cemetery here, we went here, and we looked at the tombstone of General Stephen Weed of Civil War fame, 1863, and I noticed there were fossils in this particular gravestone. Here's a crinoid sticking here, right, as you could see. So, and then we looked around the cemetery. You get to see the old types of stones here. Here's some sandstones. Here's a strange type of gravestone here. We looked at it here, and here's what it looks like. I don't know where they got that from, but it's right there. And then here's some carbonate types of gravestones, some more, as you could see, and so forth. There's another one over here. Now, as far as the serpentinite goes, as I talked about before, we have what's called NOA, naturally occurring asbestos. And I got involved with this. And the paper from Van Goosen from the USGS, he gives the locations of all of this. And here's the ones on Staten Island that they have recorded. These are chrysotile areas and so forth, as you could see in the serpentinite. And then, as you could see here, I talked about this before, the Johns Company manufacturers of asbestos goods mined about 78 tons out of this area on Staten Island, Ward's Hill, some 40, this paper came out in the 54, so probably the turn of the century, and then abandoned the enterprise that was done in sufficient quantity to repay the expense of excavating, although some of the material was of excellent quality, as may be seen by examining the numerous specimens contained there. And then they go into flag over here and so forth. So I was able to find out here that there's some material here. They have this 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 that it's a fine asbestos with fine silky fibers and so forth. And James Pierce, there was something from 1818 here. I forward you specimens of straw and rose-colored amethyst I recently met with on Staten Island, which I detach in strips from a rock, it appearing as usual in veins. It breaks up like flax and it may be spun and wove without the aid of moisture and in respect of flexibility. And the length of the fiber may be considered the best found in this country. And then, so the main type of asbestos mineral here would be the chrysotile, the visible fiber, subparallel veinlets by puffer and so forth here. Then there's some anthophyllite. And then over here, you'll see a local paper interviewed me on this. And here I am over here speaking with a colleague of mine. However, they put an asbestos extensive in the island bedrock here. The bedding may release fibers, pose health threat. When I spoke to them, you speak to the press and you got to really be careful. They took a couple of sentences out and put it right there, as you could see. And then it went on after this in 1987. Actually, the one here came from 87, June 7th, 1987. The Sunday Staten Island Advance that everybody saw there. Hillside builder hires on-site asbestos. It wasn't me, of course, but anyway. And then the threat of asbestos in bedrock catches builders by surprise. So what they did here is they went into the hill here. Just get this for a minute. And they put this apartment complex in here, as you can see. And then this comes from Newsday. And I have a clip here. The city environmental officials acknowledged recently that they have known about the high concentrations of naturally occurring asbestos on Staten Island since their own geologic study there was completed last year. The study so far unpublished, I haven't found it anywhere. They found that in 60% of the serpentine rocks sampled, asbestos levels range from 5 to 30%. So I don't know what happened after this. And then there's more articles on this back in the 1990s, sniffing for asbestos. DEP, Department of Environmental Protection, asked to see if development will store rock asbestos. And then they have some quotes from me here. And then I was interviewed by the New York Times here. And I said that disturbing the serpentine rock at a construction site could release asbestos fibers, but the Department of Health spokesman John Gadd said that a small amount of asbestos occurs in the air all the time, and that a relatively brief exposure of airborne asbestos from construction work would probably pose a minimal risk. Well, anyway. And then it was an op-ed piece on this, the asbestos on Staten Island be underneath us. And then Puffer here, 1994, he analyzed 36 serpentinite samples from 27 Staten Island localities, 66% of the regular serpentine, and 27% the chrysotile, 7% minor olivine chromite, and the magnetite. And then the chrysotile asbestos occurs as microscopic cross fiber and slip fiber veinlets in 28 outcrops on Staten Island, serpentinite, germanium puffer, 1990. They also report that typical samples contain 20 to 40% chrysotile, and that shear zones of anthophyllite have an asbestiform fiber content of 3 to 5%. So the chrysotile visible fiber subparallel veinlets, 1 millimeter wide, germanium puffer, anthophyllite, as I said before. Now, Frondell came out with a paper in 1988. What was probably the first large-scale asbestos mining operation in the U.S. began with discovery by Pierce in 1818 of a deposit at Quarantine in Tompkinsville, Staten Island, New York. Now, Beck, 1842, noted that the Staten Island material was extensively used for insulation and for fireproof garments. And now we go into the overview of the serpentine. So here's a map that came out by Puffer. You could see that these bodies of serpentinite go from the north to the south here. They're shown in red, and they're enclosed in the Paleozoic rocks, as you could see. And here's the 1902 map of Staten Island. I like this the best. It shows a lot of details. a fellow named Bain, and he was the first to work on this, and he noted that it was it was an olivine and OPX type of rock that was hydrothermally altered to the serpentinite here, and here's some of his work. I have new data on this. I've been working on this, and I've analyzed a lot more rocks. And then a fellow named Wasserman, and he did an MS type of work on this in 1956. He did a magnetic survey of the serpentinite, and here's what he found out, and so forth. It looks kind of interesting. It looks like linear types of trends here. And then the 1987 map from Little and Epstein, the USGS map shows this, and here's the map, and here's the respective cross section of it. And then I came across this. I analyzed this material here. A fellow came over to me who I happen to know, and he said they were putting a sewer in, and they got this material, looks like fibers. It turns out to be an antigerite that has a lot of nickel and chrome in it. And we did some work on this, as you could see. And we began to study because the material has a striking asbestiform type of shape. And because we thought it might be something called colosturinite, which was first reported on in '85, but it wasn't. And so it's an antigerite, and we did some HRT-EM work on this, and here's what the formula comes down to and so forth. Then I always look around Staten Island for new outcrops, and one day they were opening up the side of the hill here of the serpentinite, and I was able to get some samples here, and there's 4 different views here. It's all covered up now. They built a wall over there and so forth. And here's some of the results from it. These are thin sections here. The A over there is just dark serpentinite. The B has relic diopside in it. And the C is a serpentine. The D is a serpentine. The E is an thapholite. F is an thapholite. And the G is a relic olivine. So I worked on this with my colleague from the New York State Education Department here, from the museum, and we looked at this. Now here's some microprobe images of a chromite, and as you could see, the chromites that came out of the serpentinite here, you could see the images here. So this is high. It has a chromite. It has a lot of chrome in the core, but not too much in the rim. There's iron in the rim, and if you look at the same thing here, there's iron, a great deal of iron in the rim, as you could see here, and there's hardly any iron inside. The titanium is all the same. The aluminum is pretty much the same, and the Mg is just the same. But here's 2 different chromite grains, and they all show the same thing. They have chrome-rich cores and iron-rich rims and so forth. And then we did some microprobe type of work on this to get a better handle on this. And we plotted them up. It shows that our chromites plotted here very close to the 4-arc type of material here. And then, so we're looking at something like this. We think it's somewhere over here in a subduction zone, they call a super subduction zone area, and so forth. And here's some of the conclusions here. We go down to the bottom here. We also suggest that this metaserpentinite formed in a 4-arc region of the subduction zone. Here, the metaserpentinite, whatever you may have formed by spreading in the 4-arc region of a super subduction zone. This is in agreement with the interpretation by these fellows here, Koish and Gardner, consistent with the interpretation of the Southern Quebec ophiolites, all part of the same thing probably. And then we started to work on other types of whatever else was in this serpentine. We looked at some of the olivines here. We haven't got to the pyroxenes yet, but we will. And then there's recent work by Morse, Kellogg, and Leck here. There's a conflict and so forth between the structural and stratigraphic evidence for seafloor spreading in a non-island arc environment. geochemical evidence for derivation of magmas from highly depleted mantles, similar to the found in present subduction zones. Furthermore, oceanic paleogeography of the pre-suture ocean basin can be complex because dismembered ophiolite rocks, that's probably what we have here in the cell sequence, associated with both the mid-ocean ridge basalts, arc-like igneous rocks. So ophiolite complexes can be divided into either the Tethyan or Cordilleran, which if you look over here, there's two ways to look at this. We're not exactly sure. And actually, as you could see here, however, the issue is probably not settled yet. I guess future work has to be done on this. And now I'm working on a project here. We found I've taken these pictures a long time ago, and I have the samples, so I decided to work on it. See, here's an outcrop of serpentinite, Staten Island, the VZ bridge, the horizontal bridge to the background here. And they built up the area since then, but we found this breccia, as you could see. So it's a red type of matrix with these angular types of serpentines in them. So I think it's a debris flow, and we're working on that. Here's another sample. You could see here, there's pieces of serpentinite and other pieces. I plan to analyze each one of these to see what's in this and get a better handle on it. Anyway, I thought I was showing some groundwater issues here that are really interesting to look at. Now, here's the groundwater map of Staten Island by the USGS. And then I want to point out an article here. Now, the article came out in a paper that we no longer have, the Staten Island, it was the Staten Island paper. It's no longer out there. But this article came out June 1st, 1989, and I was interviewed here, but I told them not to publish this, but they did. Now, over here, here's a fellow. He claims that there's some kind of that springs like the pond on Toad Hill in Staten Island there are aquaflow outlets of Lake Patkong over in New Jersey, which doesn't make sense. And he says, we know this because tagged eels in the lake were found in the pond. The aquaflow is so, when it rains in Wayne, the water comes up on Staten Island. So I decided to look into this and see if there's a way of doing this. So Lake Patkong is over here, and Toad Hill is over here, and we have the Newark Basin rocks and the Precambrian rocks over here. So if you look at the groundwater map from the USGS here, this is the groundwater divide over here to begin with, and here's the water table map. So it looks like groundwater flows out here and here, and here's the reference on that. And then so if you take a look at this, and then here's the paper from the USGS. They show on Toad Hill here that the groundwater flows like this. So I don't think they can make a case for tagged eels to come up here or something. It doesn't make any sense. But anyway, so that's what that's about here. Then there was a second study that I was involved with here. A builder wanted to build some houses in this area of Pleasant Plains on Staten Island. So the problem was, we thought there was a high water table here, and the builder thought there was a perched water table, and he was going to put his septic tanks underneath the perched water table. So they came here, they recorded the blow counts, the split spoon type of samples here. You could see here's the pipe for the split spoon, and here's the one that they after they did this, they drilled with this so they could put the well in here and so forth. And here's the water table map of the area, as you can see. So the builder thought there was an aquitard here, and the water table up here was really for the aquitard, and there was a second water table down here. So he's going to put his septic tanks here under the aquitard between what he thought was the regional water table and the aquitard, as you could see. And then, the idea was, they came up with this idea, they would drill 2 wells, one deep and one shallow. And if there was an aquitard here, and they would seal the pipe here, so if there was anything, it wouldn't go in here, but it would be that there would be a water table here. And then, so the well here should show that the water was here and the well here. So here's his idea. Septic goes here and everything. But after all the smoke cleared here, it turns out there's only one water table. So that's what came out of this. I hope everybody agrees with this, no perched water table. So anyway, I don't know how much time is left, but I would like to talk about the hurricane history of Staten Island, and I'll hold off on the questions for now. So let me just share another file here. So we've been looking at the hurricane history of Staten Island here because we are in hurricane season right now. And after Sandy, we did a lot of work on this. So I just want to go through this. I put some slides together on this. So after Sandy, we were interviewed by the New York Times, and I said that Staten Island was in the wrong place at the wrong time for a storm that scored a perpendicular hit on the coast of New Jersey here. That put Staten Island in the bullseye for the surge. The water didn't have anywhere to go. So if you look at the area here, here's Staten Island. We have almost a right angle in the coastline here. Let me get my pointer here so I could see, and so forth. So Sandy came in over here, and it put us in the northeast quadrant of the hurricane where the wind speed and forward speed add up, and we got a maximum storm surge here, right there. So as you can see, Staten Island, here's a hillshade map I made from a DEM and so forth. You can see we have plenty of high ground here. This is what Staten Island used to look like in the late 1800s, and the map was published in 1902 by the USGS. So we looked at the slosh zones here at the time. They've changed them now, but at the time we were able to get these and so forth. So here's the different category 1 to 5. And so what I did here with the GIS, and I used a database from the city of New York that shows every structure and when the structure was built. So what you're going to see here are some white squares that show up of the lots that were urbanized. So before 1900, here's the category 1 zone, category 2, 3, and 4. If you just take a look at this, so between 1910 and you go down to 1900, so we get a few houses there. By 1930, it looks like this: 1940, 50, 60, 70, 80, 90, 2000, and that's for the Cat 1 slosh zone. And now we're going to add the slosh 1 and 2 here. So get this. So it keeps getting urbanized, as you could see. And here's how it looks by 2008. So we looked at this and we saw it got urbanized even though there were hurricanes here. So if you went back to the topo map I showed you before, the area here was all like coastal types of wetlands. And everybody knows that we lost 23 people on Staten Island, and they probably drowned in these areas and so forth. And then interviewed by the New Yorker magazine. So we have a hurricane history for the city of New York from 1635 all the way through here. And then here's a paper that came out, and we added Sandy to it. You could see the storm surge on this. You could see the maximum water level here and so forth. And then I went back to the old Staten Island advances, and we looked at this. Northeast appears ripe for a major hurricane. The top part here is prescriptive force, protective fence was blown against the side of the former Richmond County Yacht Club. This is from the 38 hurricane. And here's some more from that. And then you could see more of the same here. There's a hurricane in 1960. This is the St. George, the storm surge that's shown in the St. George area. And then here's one from 1960, a boat in a harbor. There was an extratropical storm of 1927, and you could see what's happened here on the southeastern part of Staten Island. And they talked about it, and more. Oakwood's awash here. This is from 1931, and you could see here from the extratropical storm of 1932 here. Here's the high ground on Staten Island, and you could see the area was inundated by this tropical storm. And then there's some images of people sort of around here in this, in the zone that was inundated. And then I saw an interesting sign here, and I'm going to blow it up here. And in this low-lying area, the last chance to buy seashore lots, a purchase here is an investment. We saw what an investment it happened to be. And then more on the flooding here, bulkheads. And then we had a nor'easter in December 1992. And you could see the waves crashing against a restaurant known as Carmen's. And then I was interviewed by the local paper, and I said something like, said the South Shore of Staten Island could be affected by a storm surge as much as 20 feet of a strong hurricane. This came out in 2009. And then we had Hurricane Irene, as you could see here, 5.72 inches of rain on the North Shores, 4.64. And then what we had here was some flooding. It was a flood event, not too much storm surge. And what happened here is that the lake over here, the outlet was blocked. And as a result of this, these streets were lower than the 34 feet. So the water came, if I just go back one, right there, and so forth. And then here's the blue belt that I was talking about. And here's a BMP for it, the BMP 8. It's a dam here that retains the water. And as a result of Irene, the water was going over here, as you could see. This is what it looked like the summer before when I took my students there to look at the spot. And then we have flooding all over Staten Island, as you could see here from Irene. Not too much. Storm surge, here's a BMP here. And at this BMP, there's a stream gauge that's no longer operating because of funding. But you could see here the water went up like that, and here's what it looked like. The water from the street was going into the stream here, and here's the USGS stream gauge box, went in like that. And then we had Hurricane Sandy. So what happened with Sandy, here's an area that you can see. Now that's the second floor of a house. The first floor is gone somewhere. So here's some of the Sandy stuff. As you know, Sandy went in, it's a post-normal type of hurricane, superstorm, whatever you want to call it, putting the city of New York here in the northeast quadrant. And so I went out the day after to look for the rack line here, and at 256 Sand Lane, which is that street there, the rack line stopped. And so here's the 256 house, here's the 14-foot contour line, here's the 12-foot, and FEMA got that. So that was the surge extent of Sandy. And then I plotted it on the outline of Staten Island. And this shows you the houses that were destroyed or damaged and so forth in 3 of the areas. But for the North Shore, we didn't have much. There's high ground there, as you could see. But in the area over here where I showed you that house where the first floor is gone, what happened here is that the first floors of these houses got put into the wetlands, as you could see. So that house went there, and pieces of the house are here, so they're gone. I came across the people here, and they allowed me to take a picture of their station wagon here that was filled with debris. Here's a house off the. Here's a house in that area. that the storm surge knocked off its foundation. And here's, I guess what happened here is that this particular piece of tree was floating, and as the waters receded, it went on one of the vehicles that was stuck here and so forth. Here's some more of the damage from that. Here's the term. And so what we basically have is a bowl here. You can see the bowl. If you take a traverse across here in this low-lying area, you could see it. Here's the bowl. So the storm surge came over, stayed here, and so forth. And here's the topographic map of this area. And what I did is I plotted on the 1902 map the sandy surge extent, which you could see over here in red. And at the time here, there weren't too many houses, but they urbanized the area. Here's some more images from Sandy. You can see, and the point here is that we have plenty of high ground, as you could see. But yet people lost their houses and cars and so forth. Here's some more of it. And so I took the DEM here and I plotted the streets and then the Sandy storm surge, and here's the storm surge and the streets. And as you can see, we have plenty of high ground on Staten Island. Anyway, food for thought with climate change. I know it's not going to happen overnight, but as you could see here, if sea level rose 100 feet, which is not going to happen in one day, obviously, with a foot, I guess the regular sea level rise is about a foot a year. This is the 100-foot contour line, so that could be a shoreline, that could be a shoreline. If it went to maximum, here's the 200-foot contour line right here. So I just made those up here. So anyway, hurricane season is right now, as you could see, and so forth. Clock is ticking. And so forth. Okay, I want to thank you for your attention here and so forth. And I'll take any questions now. So I'll stop sharing.
Hey, Dr. Benimoff, it's Chris Wenzel. I was curious about that serpentine conglomerate that you showed.
Yes.
You think that's a landslide feature, or what do you think? That's,
yeah, I found similar features over in California.
Yeah.
I'm trying to determine if that's a debris flow type of feature.
That was pretty interesting.
Okay.
It's a wonderful talk. Thank you so much. This is great content. A lot of information you packed in.
Yeah, I'm trying to give an overview and everything. Okay.
Are there any questions? If anybody doesn't have a microphone, feel free to add it to the chat and I'll read it out.
Dr. Benimoff, this is Brian Duggan.
Yes.
In the beginning, you had showed about the rocks with the diabase and then that other rock type.
Yeah.
With the T. I'm sorry, I don't have the. I didn't
It's
write
called
it down.
we tried to name it. It was a quartz albite type of granite. Instead of having K-spar in quartz, it had albite in quartz because the sedimentary rock that melted had a lot of the sodium in it and not too much of anything else. So that's why they call it so it's a quartz albite type of granite, which is also known as a Tragediamite.
Oh, okay. Is that so? Was that a shale? I thought I saw in the diagram.
Yeah. Yes. We found we have some unmelted stuff from the Newark Basin area. And it's called the Patkong argillite. So it's like a shale.
Oh, okay. Great. Thanks. And then one other question. Mentioned early on that the bedrock was included the Magathy and the Raritan.
Well, that's what the USGS has, but I'm not too sure about that. The USGS map that I showed you from Little and Epstein has it mapped as Magathy and Raritan, but there could be penstock in there or something else. I think it still has to be worked on.
But that's actually consolidated to rock, whereas on Long Island it's sand.
No, no, it's just like sand and clays.
Oh, okay.
There's been excavations there and they've taken a lot of different colored sands out and clays and things like that. And as I pointed out earlier, there was a clay quarry that they used, that they would use to make bricks and things like that. The Kreischerville clays.
Okay, thank you.
Not so much a question, but you mentioned a paper that you had written about the Palisade Sill. Is there any way that you'd be able to share that?
Yes, I can. I can share it if you send me an email. I would be. I have copies of that. It points out how all the data we used to show that the xenolith partially melted around its margins to produce the tragediamite type of rock, of magma that crystallized into a rock. And then what happened, there was diffusion of ions across the liquid-liquid interface into the tragediamite and so forth. So we have all of that. I'd be glad to share that with you. It's a 1984 paper, and I'd be glad to do that.
Great, thank you.
Anybody else? Well, it doesn't sound like it. Dr. Benimoff, thank you again. That was a fantastic presentation, and we truly appreciate you taking the time out of your schedule to come and enrich us with some of your knowledge and some of the great information you've got there about Staten Island. I thought that was great. So thank you.
Well, thank you. I could stop sharing my screen if you want to. Okay.
Yeah, go ahead.
Okay, let me see. Stop share. Okay.
All right. Well, I think that don't have trivia tonight, so that concludes our presentation tonight. So thank you all for coming, and stay tuned. Hopefully, we'll see you next month for the presentation on the 19th. Have a great night.
Doctor.
Be safe.
Thank you.